Today, we'll take a closer look at the new repeater logic, which has been made available in SwifTest version 1.1.5.0. The repeater feature was really built to allow tests to cycle through repository data store rows, which means tests can be driven by soft-coded data rather than hard-coded actions. So any changes to the data will automatically filter through to the test. Ultimately, this will lead to smaller, more concise tests, which create significant time savings, both in the creation and the maintenance of test scripts. To illustrate the repeater, I'm going to use this simple repository data store, which just contains a couple of rows of item and order quantity information. I'm going to create a test script which will read each row in this repository and write that information to a sales order detail grid. If I then add or remove rows of this repository, the test will automatically be affected by those changes. So I already have a project, a scenario, and a test set up. So the first thing I need to do is create a login action using all the default settings from the project. Then we can use FastPath to open the ZJDE version of P4210. I'm going to click the Add button so we can create a new order. And now I'm going to enter the header information. I'm just going to hard code this. This could be soft coded in a separate repository, but that's unnecessary for this demo of the repeater action. Okay, so this is where things start getting interesting. First thing I'm going to do is manually create a new runtime data store item called row counter. This is going to keep track of both the row in the repository that we're reading from, but it's also going to keep track of the grid row that we're going to be writing to. I'm going to give this a starting value of 0. Next, I'm going to increment this by a value of 1. This action will also let you decrease the row count if you use a value of -1, if you've got some reason to do this. Now, this might seem a little bit weird. We create this new runtime data store item, we give it a value of 0, and then right away we increase it by 1. So why did we do this? Well, this is going to be the first action we start repeating from. So every time the repeat action fires, the first thing we're going to do is increase the row count. So on the first run it will be 1, on the second run it will be 2, and so on and so on. Next, we need to grab some data from the repository. We're going to read our sales order repository using the value inside our row counter. And there you can see the repository data coming through. And now we can populate the grid row, again using our row count. I'm going to assign a value to the order quantity and the item number. And that's it. These are the 4 actions we want to repeat from row 7 until we hit our repeater action. And let's now create that repeater action. Let's repeat this 3 more times. That's because we've created the first row already, and there are 3 more rows in this repository. And we want to repeat from row 7 onwards. That's where we incremented the row counter. So when I execute this, we're going to see the repeater execution screen pop up and process all of those rows for us. And that's our order. We can now click OK. We can accept the order. We can maybe save the order number to be passed to another test in the scenario. And remember, a good test always cleans up after itself. So let's close our application and let's log out. So now let's take this test one step further. Previously, we hard-coded the number of times we wanted this repeat to run. But what if we add more rows to this repository or remove rows from this repository? This would mean that we would need to update this test to repeat more or less times. Another, maybe better way of doing this would be to retrieve the number of rows currently in this repository and then use this as the number of times that the repeater should run. So now if I delete a row, the repeater is going to run 1 less time. And if I add more data, the repeater will automatically run for as many rows as there are in this repository. So this way we can create much smaller, much more maintainable tests that are driven by data rather than driven by hard-coded test actions.